And here we are, gone through the first example. I haven't started recording yet. So yeah, the question was, how do we create an example with a vertical asymptote at 5 and x minus 5 in the denominator will produce it? We could do anything we want in the numerator except a multiple of x minus 5. Because if we do that, we won't get the asymptote. We'll just get a non-permissible value. So if we come in here to 5, that is undefined. Right, so that's just the point discontinuity. If we do anything else on top, then we will still have a vertical asymptote here at 5. Now, when you have 2x minus 5 over x minus 5, what happens to our horizontal asymptote? Yeah, this gives us a horizontal asymptote of 2. So this is 5, and that's 2. Okay, and why is it 2? I mean, we could see that on the graph, but how could we tell from the algebra alone?
Because if you take the x and then when you the bigger x is
Yeah, this is what Sandra was getting at earlier, but remembering the degrees are involved. When the degrees are equal, then you take the ratio of the leading coefficients. Yeah. So it's the connection. You have to check to see, are the degrees equal? And if they are, you get those leading coefficients. So let's say we have A's and B's. We'll add sliders. X is at A and Y is at B. So we'll keep A there, but we'll change B. Let's make B go from 2 to 8 in steps of 1. Okay. So this has built us a function. This is 2x minus 1 over x minus 1. So our vertical asymptote has moved to 1, and our horizontal asymptote is still at 2. But as we cycle through different values of B, we see how that ratio changes, and our vertical asymptote moves. We could cycle through different values of A, and we see how that moves our horizontal asymptote. Now, what do we notice about what happens when our A value crosses that y-axis? Yeah, the hyperbolas change position. When our A becomes negative, right, then as x becomes greater and greater, we end up with that, right, it gets down to a negative value here. So if we pause it right here, right now when x is 5, okay, sorry, I need to pause both. So right now when x is 5, we have a positive numerator and a negative denominator, so we have a negative value of the function. But once we pass that 0, right, when x is minus 5, then we have when a is minus 5, we still have a negative number up top at minus 5, and a negative number, the numerator will be a 4 times negative 5, so that's a negative 20 plus 6. So that's a negative 14, and then a negative 5 minus a negative 6 is a negative 5 plus 6, so that becomes positive. So we have a negative value here. But as x goes to positive infinity, it still comes up to this asymptote. But now it comes up from below, because as x approaches this limit from the right, we're going to negative infinity because of that minus a bit. So every time a and b flip, we'll see that. If we change our b values, so let's just hit our odd numbers, so we know it's always positive or negative. Step 2. And I'll pause the A. So we can see now it's upper right, and then as our Y flips, it comes out on the other side too. So as we cross these axes, the hyperbolas will also change positions. Right? Does that make sense to everyone? All right. Okay. So what happens when the degree of our numerator is greater than the degree of our denominator? What happens to our horizontal asymptote? You're right. If the degree of the numerator is greater, we have no asymptote, because then, right, our leading coefficients are like bx over x. So it's like bx. And we get a straight line here. It's like a straight line with a slope of -3. So if we were to actually plot y equals, we'll just go bx. You see they kind of come in parallel, and in the long term it will sort of approach that point. Okay. So what happens if the degree of the denominator is greater than the degree of the numerator? Yeah, if our denominator has a greater degree, then it behaves more like b over x. And as x goes to infinity, they come down to 0. So we can see that here, the horizontal asymptotes will go to 0. So that's a little bit of a nutshell with graphing. Now we need to look at adding them, right? Because the operations on it are how we add, subtract, multiply, and divide. So we'll do a little bit more with the graphing next week, because that's really RF1. It was just a quick review to get into RF2 and RF3. So if you have 3 over x plus 5 over x minus 1, what do we get? How do we solve this?
First, we multiply both denominators on each side, like the whole equation on each side.
Yeah, the first thing we have to do is put them over a common denominator. So this 3 over x gets multiplied by the other denominator on top and bottom, and the 5 over x minus 1 gets multiplied by x on top and bottom. That gets us to our common denominator. What's our next step?
FOIL, right?
Yeah, the distributive property. And our next step?
Like terms?
Yeah, we collect like terms. Now there's nothing here that we can simplify or cancel out. These terms both have x's, but this one does not. So we don't have an overall common factor of x that we can factor out. We can only cancel things if we can write them in a factored form. Because this -3 does not have an x, we cannot factor an x, we cannot cancel this. These numbers aren't the same, so we can't cancel that one. I mean, we could pull a stunt like we did with completing the square. Sorry, don't know why I blanked on the name. Right, and add 5 and subtract 5 here so we can get an 8x minus 8. But then we still can't cancel the x minus 1 because we'd have that plus 5 floating around.
We never we never use FOIL for the denominators. Like we just leave them as is. We just keep them together.
Yeah, you never have to multiply the denominators through. You can leave them in the factored form. It's often easier to see what's going on in the factored form, right? Because if we have, say, if our denominator is x minus 2, x plus 3, even though I'll produce a trinomial, which we don't do in 30-2, you've seen them in 20-1. But this is easier to look at that and say, all right, x cannot be 2 or -3. We're going to have vertical asymptotes there unless that factor cancels in the numerator. That's much easier to see in that case than it is in this one. right? This one, if we're going to get anything useful out of it, we have to turn it into that. So we can leave everything in the factored form. We don't need to multiply it out. The only time you might need to multiply it out is to find your answer in a multiple choice question. So if the multiple choice options don't have it in the factored form, you might need to multiply it out and look for that on the list. But in the real world, right, written response, you will never have to multiply those out. All right. So how about 3 over x minus 1 times 5 over x minus 2? What do we get from this?
We just always multiply more because we got 1,000.
Yeah, with multiplication, that's probably the easiest that this is going to get. You multiply them as is. The top is just constants. We collect like terms there. And we don't have to multiply the bottom. We can do that factored, so we're done. Yeah. Okay, so let's see. Minus 2 over x minus 1. Yeah, this is going to be the more challenging questions. This is about as tough as they get. So I've already heard someone mention what the next step is. So, oh, right, yes, and Mila has said NPVs. So we always want to specify our NPVs. So up here, in our first one, x is not allowed to be 1 or 2. What are the NPVs in this one?
It's going to be 1 positive 1 negative 1.
And then when we reciprocate, it's
Yeah, and
1.
then
Yeah, and then once we've reciprocated this, we are going to end up with a 4 over 6, which reduces to 2 over 3. So that is pulling the NPV from the next step. And the only reason we know that is because our next step is to reciprocate and multiply.
you can cancel 3x minus
Yeah,
2, like
that's
you're
what
a
I'm
calculator.
Yeah, so we am hearing in class here. So for the next step, this we pull out a common factor of 2. I'm seeing that in the chat as well. We factor. That common factor of 2 in our last binomial just leaves us with a 3x minus 2. And yes, now those cancel. So we are left with x plus 1 over 2 times x minus 1. So that's all we can do. Because this is there's a sign difference here, they're not exactly the same, so we cannot cancel. If these were both either x plus 1 or x minus 1, this would reduce to 1/2, and we'd have 1 fewer NPV.
We just leave it like that.
Yeah, we just leave the 2 like that. It's not wrong to write it as 2x minus 2, but it's not required. So again, the only time you might have to do that is when you're looking at, it's for a specific type of machine score question. So either multiple choice where it's done like that, or you could have a question where they say your answer will be in the form a plus b over c plus d. Put a, b, c, d in your numeric response. Right. And, oh yeah, these would have x's. So then because they don't have brackets in this form, you'd have to multiply it out. But then your d would have to be positive, or it'd be cx minus d here. So, yeah, multiplying the denominators is not something you have to do naturally in the real world. Sometimes you have to do it just to line up with machine score and test questions. All right. So what about problem solving? So let's say we have 3x minus 1 over x plus 5 equals 4x plus 7 over x minus 2. I do not guarantee we're actually going to have answers to this question because I'm making it up as we go along. But what is x? Yep, we've got a reminder to do the NPVs here.
Yeah, so negative 5.
Yeah. Negative 5 and positive 2. So yes, and cross multiplication is an effective next step here because nothing's being added or subtracted. It's just one fraction equals another fraction. If we had terms being added or subtracted, we couldn't cross multiply.
I just want that with the addition on the other side, it gets like long. Like the steps get long.
Yeah. Okay, what's our next step?
I'll move everything on one side, maybe, or multiply both.
Yeah, this is where we use our distributive property or FOIL. And then our first is 4x squared. Outside is 20. Inside is 7. Last is 35. Now what?
Now you move everything.
Yeah, now we move it all to one side. So that's x squared. The 7x goes to there to make a 34x. The 2 comes over here. We get a plus 33. And holy cow, this one I made up out of nowhere is actually going to give us 2 integer solutions. That's extremely rare.
The quadratic equation.
Yeah, you could use the quadratic or you could factor. I heard the quadratic first, so that's what we'll do. Because that's good practice. So minus the square root of b squared minus 4ac. So that is a negative 34 plus or minus the square root of 34 squared minus 4 times a times c all over 2a. Well, 17 squared is 289, so we'd multiply 289 by 4. So 289 times... Pardon? Yeah, we can look at this and factor it as negative 1, negative 33. But sorry, if we do just work out the whole determinant here.
And you gotta like put the number in non-numeric. If you just put it in the fact, like after it's a good.
Yeah. And that's the square root of 1024 over 2. So x equals negative 34 plus or minus 32 over 2. So when we use the addition sign, we get a negative 1. When we use the subtraction sign, we've got a negative 66 over 2, which is our negative 33. So it could factor to the x plus 1, x plus 33, which you might have been able to see with the x squared plus 34x plus 33. All right. So, yeah. So this is how we do that. Now, one final step, we come back and check against our NPVs. So we have negative 5 and 2. So these both check out. Those are not on the NPV list. So if we had a -2 or a -1, if that was on our list of non-permissible values, this -1 would have to be rejected.
That's what I think most of the time is like that rather than you.
Yeah, so if we end up with, so if we have NPVs and, so let's say we have x squared minus 7x plus 10, and our NPVs are 2 and 3. We have this equals 0. Factoring this out, our x would be 2 and 5, because 2 times 5 is 10, 2 plus 5 is 7. So we have x minus 2 times x minus 5. And then we would have to reject the 2 because it's an NPV, but we could keep the 5 because it's not. So we always have to check our NPVs. So and like I said, I've said it before. Mila clearly remembered because she was doing that. The very first step, start cataloging your NPVs, because after this much algebra, it becomes very easy to forget to go back and do that. So if you do it at first, you only have to remember to check it. But if you do end up forgetting something after a long question, you will get more part marks for forgetting to compare to the NPVs than you will for forgetting to figure out what the NPVs are in the first place. And in fact, most of the time, if you check the rubrics, I've got marks just for the NPVs and marks for the solutions. So may give you a little bit of a hint, because when I build the rubric that way, when you look at your written response, that's kind of broken out. I won't promise that's there every time, because that's the way I build questions. If I find a good looking question in the database, I don't necessarily go back and check the rubric to make sure it's done the same way. So sometimes I don't catch that till I'm marking it, in which case it'll be fixed for next year. All right. So any questions about this? Okay. Okay, so those are, right, that's the core end of those review. It's figuring out how to do the options. So remember, it's add, subtract. When you're adding and subtracting, you find that common denominator. Multiply. This is the only one where most of our instincts are going to work for us. Now, if you divide, that's reciprocate and multiply. And in all equations, right? So when you have that equal sign, you always remember to check your NPVs. So those are the big points. Those are the keys to study. If you keep these in mind consistently, and remember how to work with these as we've been doing since 20-2 and even a little bit of 10C and 20-2, or 20-1 and 20-2, just a little bit of 10C, you will be okay. So does anyone have any other specific example types they want us to go through?
No.
Okay. Then one last thing I'm going to do just as general midterm prep advice. So those of you online, you might have access to that student version of IXL. I'm not going to ask you to share your solutions, your performance, but can you let me know if this process works for the students as well as for the teachers? So from the teacher, I can go to learning. And then down here, there's the recommendations. There's your math, your English skills. You guys have the provincial curriculum tab as well?
Yeah, I think so. Yeah.
Okay, excellent. Because the easiest way to prep for 30-2, you come into the provincial curriculum, you go to grade 12, and you say, show me math 30-2. So the logical reasoning and probability is what we'll be doing after the midterm. Relations and functions, all of this is before the midterm. And here that's RF1, RF2, RF3, 4, 5, 6, 7, and 8. So you notice it doesn't cover everything that we're doing, but it does cover a chunk of it. So these are good ones to go back to. So right, we've got that. So RF2 and 3, this would be a good one to review and do some practice on before the midterm. 4 and 7 we'll be reviewing tomorrow. So 4 is a good one to review before the midterm. 5 and 6, and then I think I had it broken into 4 and 8. Those are the retests next week. I believe that's the way it worked. We could double check the calendar. So yeah, it is 1 and 8 on Tuesday and 5 and 6 on Thursday. So 1 isn't listed here. 8, there's lots.
1 is the region.
Yeah, it's the equivalent form. So that's looking for the common factors and canceling. So 8, this is a really good area to explore and practice before the retest next Tuesday.
RF8 is logical and sinusoidal.
Yeah, represent data using sinusoidal functions to solve problems. So this doesn't have any of the regression skills. That's why there's not a lot for 6 or 7. But it's really good for 8 because this is your first exposure to actually graphing sine and cosine with the full domain. So that end, more than the regression end, is very well represented here. So that would be my advice, that there's almost like a built-in study guide. And then after the midterm, the rest of the course will be here, the logical reasoning and the probability. So, and most of these you will have seen before, because frankly, that's something I was consistently looking at when I was picking out your homework assignments. So I was going to that correlation and saying what fits, and then checking others, because there's other things in that neighborhood that aren't explicitly listed that I do think fit anyway. So might have Y3 and Y5, but they don't include Y4 for some reason, when Y4 is a skill. So, okay. All right, so if there's no other questions, I will share this lim board of the Desmos graph, I guess just on the stream, because there's, maybe I'll put it in the midterm itself or in the retest or something. Yeah, it'll be in the midterm itself, because we don't have retest for these skills. But yeah, I will link these so that you have midterm review content. Okay? And yeah, if there's no other questions, you guys are free to go.
So next year,
Yeah.